Hello, good afternoon. Welcome to the X-tendo webinar series. Today, the topic is EPC databases and how can EPC databases be used to increase the quality of EPCs. My name is Lukas Kranzl. I have the honor and pleasure to, together with Ina Maya, coordinate this project and will guide you through this webinar today. Next slide, please. Before we start, some technicalities and rules for the webinar. So first, how to ask questions. Please use the chat function to ask questions during the sessions. So you can see on the bottom right the button for the chat. If you need some technical support, please address technical questions also through the chat function to Roberta D'Angiolella from PPIE. Also important note, today's presentation is being recorded and will be sent to all the registered people after this webinar. Next slide, please. X-tendo is a project, a Horizon 2020 project, with the objective to improve and enhance energy performance certification of buildings. And we have structured and organized the project along 10 features, how we called it. 5 of these 10 features are dealing with innovative indicators like smart readiness, comfort, outdoor air pollution, real energy consumption, and district energy. And the second 5 features are dealing with innovative handling of EPC data. And here we have EPC databases, the billing logbooks, tailored recommendations in financing options, and one-stop shops. And these 10 features form the structure of the project, and one of these features, as you could see, is dealing with EPC databases, and this will be the focus of today's webinar. Next slide, please. We have a series of quite interesting presentations prepared today. Christian Lund Iversen from the Danish Energy Agency will start with the an overview on EPC database in Denmark. Then Ina Maya will give an introduction into the X-tendo methodology and progress and activities in this part of the X-tendo project dealing with EPC databases. And then we have 3 country-wise presentations where we started the implementation or tested this feature of improved, enhanced EPC database quality control. In Italy, here Fabio Zangarella will have a presentation, Greece, George Koras, and Denmark, Kasper Thielsen. And in the end, we will have a panel discussion, and I hope you will be very active in also adding your questions, ideas, comments, suggestions, and addressing them through the chat to the panelists, which will take them up in the discussion. So with this, I hand over to the first presentation. Christian, please, your floor is yours for the overview on the EPC database in Denmark.
Thank you, and thank you for having me. I'm Christian, and I will talk about the EPC database in Denmark. I'm working with the EPC team here in Denmark, and my job is to maintain and develop all the systems around EPCs here in Denmark. And one of the systems is this database. I also do a lot of statistics and that stuff. The agenda today is I will talk about how the EPC is looking in Denmark. And then I will get into the some of the data validations we have, the data quality, and also the control scheme we have here in Denmark. And then last, I will talk about how we have opened the access to the database and all the EPC data. First of all, I will talk about the EPC database. There have been made EPCs in Denmark since late 2006. There have been made approximately 1 million EPCs, and we have all these reports in both of course, a PDF file, but also a XML data file. And that is shown here, a small sample of the file, with all the building data and so on. The database is a SQL database, which is a structured database, and I have made a small picture, which you can see here, where we have structured all the data from the EPCs, all the building data, all the great stuff that is registered out there on the buildings, so that we can make a quick search about windows, about floors, and so on. This year, we have, for now, we have made this structured database in about 50% of the data we have structured right now. But we hope that by the end of this year, we have structured all the data in the EPCs, and that is quite a lot. And in this way, we can make a quick search in our data and quick use of and analyze all our data in these 1 million EPCs, which will be great. Next up, I will talk about the validation. Here. Our EPCs are made in a reporting program by the energy consultants. In Denmark, we have two programs that can make EPCs, and they are approved by us here in Denmark. In these programs, we have made about 400 validations that Kasper and I have made, and our team have made, so the reporting program have a baseline standard for all these data that are submitted in the EPCs. After, when the consultants are submitting these EPC, we have a so-called XSD, and that is a technical control of all these data elements in the report. So we are making sure that all the data is in the right format. When you only can submit a number, you can only submit a number, and all these controls we have about the EPC. And that is so that the quality and the of the data is as good as it can be. Last, we are using public datasets with building data, with address data, and so on. So we are validating that the consultants are using the correct addresses, the correct property numbers, and so on. So we can, when they submit the EPC, we can always find the EPC again, and I'll show how we are using these all these data later on. And all these validations is to make sure that the data quality is not perfect, but as good as it can be, and that is very important for our work with the database and when we make statistics and so on. Then I will talk about our control schemes in Denmark. And we have a old scheme that we used to have, and that scheme we took out about 150 EPCs that were randomly chosen every year, and we controlled all the data and the EPCs for the with on-site audits. So we controlled that they were making the EPC correct. In this way, we thought that the control scheme were a very small sample of the EPC. So we only controlled a small. We didn't get the outputs we were hoping, and we didn't get a clear findings of where we need to be better and where we can guide the consultants in a better way. So we needed to make a new control scheme, and for that to happen, we needed to commit ourselves to get better to SQL, which again led us to be better in the database world. We got some SQL training and education. Several of our staff here, and got so we could use our data in a better way, and then we could make a better control scheme, which we have now. What we have now is a new risk-based control scheme. So we are taking some themes that we are working on, and we are searching the database if there were missing elements in the EPCs, for example, missing roof, a missing floor that cannot happen in a correct EPC, and then we took those out in a on-site control to figure out what have happened in these cases, and instead of we only had a couple of instances every year, we have a pool of 50 to 100 EPCs with the same problem. So we got to work better with the problems and made better guidelines. And also, most important, we made, which I have shown in the bottom, we made a better validation program. So we based on these findings, we made validation that in the reporting programs that validated if they were missing a roof, a floor, and all these things that we find in these control schemes. We also made some cross-check on our data inputs if they were both we took two data sets and cross-checked them if they were wrongly inputted. We also did have some themes. We checked, for example, new buildings to see if a pool of new buildings, how the quality was, and then made better validation based on that. We also took some behavioral tendencies. For example, if the consultants made 10 windows with exact same data sets, which is not wrong, but it's not how to say it not occurs. It should not occur often. In that way, we learned how we could tweak our validation even more to make some guidelines that prevented these tendencies. Some future perspective in our work. We are right now making a big data warehouse with all our data and all the Danish energy entity, our data, to put them together and make even better data and even better analysis and so on. We are using these data mining. We will use data mining to make pattern evaluations and predictions of EPC, even or some automation in our caseworks and so on. And in that way, we are making a better control scheme and a better data quality with this data mining. Last, I will talk about our open access, which I hope I will make. The open access, we have an API access, which is an online access to display all the EPC and all data. We have in our team, we have made a map in all Denmark where you can see all the EPC in all buildings that have EPCs. So, for example, here you can see that many of the buildings have EPC that's A. The users of this API is, of course, real estate agencies, finance world, the municipalities, research, education, and so on. We have approximately 5 to 10 million requests per month. That's shown in the bottom. I have two examples here. First of all, the API access. It's a quite technical API, but we have online documentation, and you can connect to with your own programs such as Postman or Python and so on. I have two examples of use cases in Denmark. First of all, the real estate agencies. I found an example here where they have made a so-called climate calculator based on our data, where they have, I know it's in Danish, but they have calculated how much it would take to make some what's called promoting recommended proposals, how much that cost and how much they would save doing that, and how many years it would take to pay back. And also they have shown how many trees are using the same CO2. So I thought that's a nice example of using to get out to the customers. Also, I have found a use case here from the finance world where they have made they have shown the green investments and they have made a house here, and that is connected in real life to our database. So they've shown how you can better the roof, how much CO2 you are saving, and how much money you are saving based on the EPC. And you can click on all the icons here to and even how to get from a G EPC to a D. So I thought that was quite funny and a great way to show how the database is used in Denmark and to promoting the recommended proposals here in Denmark and making all the buildings greener. Yes, I think that's my time here, and thank you for my emails here, and you can put up some questions.
Yes, thanks a lot, Christian, for these in-depth insights of the Danish EPC database. I'm really happy that we have you here in this webinar to present this and discuss these experiences. And for us, these experiences or the experiences that you made with the Danish EPC databases were really inspiring. Also the work in X-tendo, and Ina Maya, my colleague at TU Wien, working as a researcher at the Energy Economics Group, will present now an overview on the methodology that has been set up in the frame of the X-tendo project to implement quality checks in EPC databases to be then tested on the case of 3 countries. Ina, please, the floor is yours.
Yes, thank you, Lucas, for the short introduction. We can start with the next slide. I will provide you an overview about the EPC databases in the X-tendo countries, and also will give a short introduction about the feature that we implemented. So by starting, the EPC databases under the EU member states are very differently implemented. There are very different solutions in between the countries. We heard that this interesting example from Denmark, which is a very far in terms of implementations of the EPC database, which in a way englobes and includes different aspects, as also shown by Christian in his presentation. So it's about the IT infrastructure and the data storage, is about the acquisition and extraction of the EPC database, of the EPC data, also data mining and maybe operating with other national registers. Of course, the quality control and the validation of the data. And as also Christian showed, especially in Denmark, this data accessibility and making it available for publicly available. In the X-tendo project, we focused on mainly 3 countries, Italy, Greece, and Denmark. And these countries will be also in the focus of my presentation. Next one, please. So basically, the first step that we had in the project was to understand the current state. There is a project report on that. I'm just summarizing in this table some of the aspects that we compared between the countries. So we had a look on the ownership of the database, about the EPC quality assurance routine, some criteria for EPC selection, and also the EPC input data in the database. Basically, the partners that we had on board are operating their national databases. Especially in Italy, there is also a regional database. So the national connects to the regional databases. In terms of quality assurance, in all countries, all of these countries, there are already some routines, especially in Italy, for example, they have some routines of quality assurance already at the national level, and during the X-tendo project, we were then assessing the partners to implement some routines in their national database. In Denmark, as also Christian presented, there are insight visits, some random verifications, and also, which is a very particular approach to Denmark, the risk-based EPC validation. While in Greece, they also have some automatic validations of input and output parameters and manual verification. In all of the countries, the EPC to be chosen and verified is mainly selected randomly. And in Denmark, they are going a little bit further already and have this risk-based approach. And all the countries, they also save some parameters, which varies according to the countries, but a large number of parameters that are also stored in the database. Next one, please. Yeah, so what is then, considering that all countries already have a well-established and a structured EPC database, we were thinking about which contribution the X-tendo project could have. So it was important, of course, that the EPC is issued and stored in a machine-readable format. That was the case for all of the countries. They all had a good amount of EPC data already with some quality control routines. So what could we then propose in the X-tendo methodology? And we decided then to first help them to establish a routine for EPC control in the databases, going further than the random selection that is done in most of the countries, and also helping them to embed some quality control routine in the long-term strategy for improving EPC quality and trust. So next one, please. If you have a look at the EPC issue process, in general, of course, the EPC starts on the decision, but in all other issuing phases, we could also implement a quality control routine. For example, if we have the data selection, we could help the EPC trainer and issuer on improving the quality of this task by, for example, providing more trainings and helping them on not repeating some mistakes. In the calculation procedures, we can control the input data, maybe support the issuer by having some automatic messages. Then after the calculation, then also validating the output of the calculations. But in the X-tendo project, we are focusing on the EPC database when it's already in the database. So the EPC data there is already in the database. And here we are then establishing a routine that could also serve as a comparison between similar buildings and also controlling the output data. Next one, please. In some for the project, for the methodology, there were some general conditions that we understood that will be important when thinking about implementing this feature, the EPC database. So first, the fully digitalized format and the well-established infrastructure, so a capable server, also the machine-readable aspect of the EPC. There are some countries that still have for example, only the PDF format of EPC. So in these countries, for example, the XML format or other machine-readable format should also have to be implemented. And also, as Christian said, it's important that there is database, SQL format, that we can do the queries of the database. And in our case, we implemented the software in the Python language. Of course, it's also crucial that some programming language is, yeah, it's possible that to learn it. And next one, please. Then here in this slide, you see the overview of the IT architecture that we proposed in the feature. Mainly the aspect of having a core module, but also having a flexible structure that enables the interaction with the EPC database. So basically what we thought about in the solution that we came up with was that we have the national database in their own national format. Then we implemented a DAO interface that talks with both our code and also the database in the national format. This DAO has and extracts all the parameters of the EPC that will be then used in the code. Then we have the core module with all the calculations, and some calculations are common to all countries, while others are very country specific. Next one, please. In the next slide, I will show you how the proposed method. So basically, we have, if you have a look at the whole process and possibilities, we start with the EPC. Then the EPC is entering the EPC database, and in the database, it will go through the first verifications. And in these first verifications, more general, verifications are done, like if some fields are missing or if some small lists are, or if the lists are completed. So very, I would say, very broad verifications. Then if the EPC is valid, it narrows down to a second threshold value classification where we decided to do here the clustering. So here it was important to define parameters that would be then specifically checked. And then for the check, while after checking all the values, the EPC was flagged and received a score. According to the score, we could say that it's valid, and if it's not valid, it will go to the EPC control and also the verification of error notification. But basically, these two last steps, they were not part of the X-tendo approach. What we also have is that if after the flagging the EPC and the score, it can go back to the EPC issuer in terms and help him or her to avoid repeating the mistake. So basically this is the overall methods that we developed for between the X-tendo scope. We had Italy and Greece focused more on the first and second thresholds value and the verification of the EPCs, also flagging the EPCs according to the validation. And in Denmark, we had this feedback loop, and we tried to understand how the outcomes of these verifications could then also improve the learning and of the EPC issuer. Next one, please. Then just a very quick understanding about this definition of this threshold value. We followed the following approach. We first, in this project, we have the opportunity and the possibility to work with the data in the databases. So we did these assumptions and did these definitions already based on the EPC data. It was quite helpful because we could then not only provide I would say theoretical methodology, but it was already being applied during the development. So we did country specifically, we defined the EPC parameters that would be verified. They were different for Italy and Greece, some of them. Then we defined some variables that could define the clusters. And here the building cluster, what I call is, for example, we have a cluster of residential building built until 1910 in a subtropical climate. And all of these definitions, both the clusters and also the variable, which would be the building use, the climate zone, and the construction, and the combination of this, and also the subcategories of each of these variables, they were defined country specifically. So at the end, we had many clusters for each of the countries. And then to define the value itself, we did analysis with percentiles, trying to understand which would be the right percentile that would allow that not all of the EPCs are not valid, but also making it sure that some considerably good values are set. And at the end, we came up with the 99 percentile for this first phase. Yeah, next slide, please. So this is the last one, and it's about the general conclusions of the methodology and also about this exercise of developing this methodology for the EPC database feature. Mainly, this code developed, it's tailored, as I said, for a national specific context. So it cannot be directly replicated. It has to be adapted according to the national specificities. The threshold value had to be very carefully defined, as we didn't want that at once all EPCs are not valid or failed the scheme, but the partners will show more later the results from that. And yeah, depending on the IT infrastructure, it could take many hours or even days. So it was very important to we recognize that this aspect of the infrastructure, it's very important. We coded and implemented in Python. And of course, if there is the need of better performance and so on, the code can be further developed in other languages. Yeah, we have all these documentations. I put some links here, and thank you very much.
Yeah, thanks a lot, Ina, for this overview and presentation of what we did in this part of the X-tendo project. And in the following three presentations, we will now go through the 3 countries having tested some aspects. And we will start with Fabio Zangarella from Enea. Fabio is an expert for EPC databases at the national level in Italy, and has implemented and tested this feature for the Italian EPC database. So please, Fabio, the floor is yours.
Thank you very much, Lucas, and good afternoon, everybody. I'm going to share our experience and our insights with the application of the feature. So how was the system test in Italy? So we tested the Italian National EPC database, which is based on which is a database based on PostgreSQL. The test was performed not in the actual EPC database, but in a test environment. We used the Python code developed by TUVN. And the test was divided in 2 different level of checks. First level of checks with the 46 parameter checked, and a second level of checks with the 11 parameters, 240 clusters with corresponding 2,640 threshold values rules. So regarding the first level checks, we checked 46 parameters. And this kind of checks was actually basic and formal rules for each parameter to check, for instance, if the values is present in the database and it's formally valid. So in the first level check were not controls on the verisimilitude of the value. For instance, we checked if the parameter in the database was not null, or if some parameters were bigger or equal to 0, depending on the parameters. So at the end of the first level check, to each verified APC was assigned a first level risk value, which is a number between 0 and 1 for each APC, depending on the number of rules not respected. So if there are no not respected rules, the risk value is 0. If there is one not respected rule, the risk value is 0.02, and up to 45 not respected rules, for which the first level risk value is 1. Then we identified 5 critical parameters for which not respected rules send the first level risk value directly to 1, and these critical parameters are energy class, building heating energy needs, and global carbon dioxide emission, global primary energy demand renewable and not renewable. Then we switch to a second level check, which is more related to a quality control of the data. We checked 11 parameters, and we divided the EPC present in our database into 240 clusters according to the building type, which can be residential, offices, commercial, industries, and other. The construction period, the climate zones, of course, according to the climate zones present in Italy, and the fact if the EPC was issued for a renovation or not. So we calculated the 2040 percentile threshold value. So we calculated the 99 percentile value in each cluster for each parameter. And also for each of the 11 parameters, we defined also absolute lower and upper limits. So the rule for each parameter in each building cluster was that the actual value had to be bigger than the lower limit and lower than the minimum value between the upper limit and the 99 percentile. Again, a second level risk value was assigned to each APC, and this risk value was a number between 0 and 1, depending on the number of rules not respected. So if all the rules were respected, then the risk value is 0. With one not respected rule, the risk value is 0.09. And if all the 11 rules are not respected, then the risk value is equal to 1. The code developed by TU Vienne gives us as an output 2 database output tables. The first one is the building check table, where we can identify the APC ID, the building cluster of the APC, the level of check, and the corresponding risk value. So here you can have a print screen of the table. And then a non-conformity table where we can see the APC ID, the checked parameter, the unsatisfied rule in case there is a not satisfaction of the rule, and an error description. And this is what we can see as a print screen of the table. Well, which are the major keys developing, the major key steps developing the feature? So there are the key steps are, well, first of all, the definition of the tested parameters for first level check, which must be done by the implementing country. Then the definition of the testing rules for each parameters for the first level check, again from the implementing country. The definition of the tested parameter for the second level check, the definition of the building clusters, the definition of the absolute lower and upper values, and the calculation of the 99 percentile threshold value, which of course may vary according to the actual database. So if you perform the testing in different period, then probably the consistency and the number of parameters in your database may vary, and also the 99 percentile may vary and need to be calculated again. The code development, customized on the database of the implementing country, which must be done by developers. A continuous interaction between the developers and the implementing country was crucial for the development of this feature. And then the two test phases on the EPC database: a preliminary test on a limited amount of EPCs, and then the test on the entire EPC database. So some testing results. First of all, the first issue we observed was the execution time. We tested the tool and the database on the same local machine with, let's say, a dual core with 96 gigabytes of RAM. And the execution times seems to vary according to the dimension of the database. We started with the development phase with a very limited number of EPCs, with the ability of the code to process more than 1.5 million EPCs in a day, but applying the last version of the code on the dimension of the actual database, then we were able to process approximately 37,000 EPCs a day. So some results for the first level check. We tested almost 2 million of EPCs. It ended up that at approximately 56% of EPC had the risk value equal to 0. Then there is a more or less 30% of EPC with a moderate risk value between 0.02 and 0.2. And then there is a remaining almost 15% of EPC with a risk value equal to 1, which is the maximum one. So you can see this. So we thoroughly investigated this almost 15%, which was, according to us, quite big. And here we found a second insight about the development of this feature. So we found that when defining the first level rules, above all regarding parameters which send the risk value directly to the maximum value, it is important to avoid the parameter interdependence. So we found out that of this 14.8% of the maximum risk value, 14.5% was related on the failure of the energy class parameter, which was one of the 5, let's say, critical parameters. But so we defined the energy class rules also depending on a second parameter, which is the reference global primary energy demand not renewable. So the tool calculated again the energy class, taking into account 2 different parameters and recalculating the corresponding energy class. But in the absence of the reference global parameters, the tool was not able to calculate the corresponding energy class, so it flagged the energy class parameter as an error, but it was not actually a true error. So the parameter of the energy class parameter was not really wrong, but the tool was not able to check its value. So we found out that a missing value on the reference parameters led to an energy class error, but this could be misleading. So, for instance, of these 14.5% of EPCs with energy class error, about 12.8% was depending on the missing value of the reference parameter. So only 1.7% of EPC had really an independent energy class error. So let's say, taking into account the energy class error, let's say not dependent on the reference parameters, then the cumulative errors for the critical parameters are about 2.1% of the total of the EPCs. So this is one of the insights that we found. Then the second level checks, again, we tested almost 2 million of EPC, and we found that approximately 75% of EPC had a risk value equals to 0. approximately 24% had a risk value between 0.09 and 0.3, and the remaining 0.5% had a risk value equal or greater than 0.45. The most unsatisfied parameters were the APH not renewable, the ratio with the APH ND. And then we did some consideration about the building cluster. So we found out that the building cluster with the highest cumulative second level risk value are the residential building cluster, and that the building cluster with the highest average second level risk value are not residential. Final insights from our testing of this feature is that the feature needs to be developed specifically for the database of the implementing country. In order to operate it and to implement it are required IT skills to operate on a database and also a deep knowledge of the EPC scheme. The feature can find errors and inconsistency in the database data, and the 2 degrees of riskiness are assigned to each EPC. One, identifying possible missing data, and the second one, the latter, identifying possible significant differences from the bulk of the EPCs stored in the database. So with the results, it is possible to identify risky EPCs, but also risky building clusters and risky parameters. We found out that the major challenge is the high execution time of the code. So with the actual code, with the actual execution time of the code, it is thinkable to run it on the whole database just a few times in a year. So probably a faster programming language could be advisable. And finally, special attention must be paid to the definition of the rules, especially to avoid parameter interdependence. And if there are some, and if there is any question, maybe in the panel later.
Thanks a lot, Fabio. Indeed, we already received some questions, and we will come back to them in the panel discussion. Thanks also to the audience for the questions so far. In a similar way as Fabio has presented the results for the case of Italy, George Corras will now give us some insights how EPC database feature and quality assurance measures has been tested for the case of Greece. CRES is the responsible institution in Greece for operating the EPC database, and so George is again the right person, I think, to show us some insights of this feature implementation. Please, George, the floor is yours. We cannot hear you, George. Seems to be some problem.
George, can you please try to change the audio setting on the upper bar? Thank you.
No, we cannot hear you. No, I wonder whether we could, in the meantime, maybe continue with Caspar, and or I don't know, Roberta, do you have another suggestion?
No, yes, we can continue with Caspar and George. Maybe if you can leave the meeting and enter again at this point, because yeah.
Yeah, Thanks. Hope we can clarify and solve these technical issues. Yeah, then I propose to continue in the meantime with the presentation of Kasper Thielsen. Kasper is a colleague of Christian at the Danish Energy Agency, also working a lot with the EPC database in Denmark. And Kasper, you will now present the activities that have been carried out in the frame of the EPC database feature in Denmark. Please, Kasper, the floor is yours.
Thank you very much. George, we can still not hear you, but I'll continue with my presentation. Yeah, so I think you can see my screen now.
Yes.
Perfect. Yeah, so first of all, I just want to present the current status and then just to put some perspective on what we are talking about today. So before we have the EPC issue, and we have the education of EPC consultants, as we can see here, but we also have supporting the consultants our EPC legislation. And then when the consultants are educated in, of course, in the by our courses, they are. It is possible for them to perform the EPCs here from our database. But the most important part is here we have implemented validation of input parameters in our EPC, and I can see that that was also one of the questions in the chat. So where should the validations actually be implemented? So we have implemented it in our EPC issuing programs. So they are also based on a traffic light system, as I will continue with in a second. But they also have to be within a range of values before they are actually submitted into our database. And in our database, we have approximately 1 million EPCs. They are not all valid, but we have been issuing EPCs since, as also Christian mentioned, since 2006. And just to put some perspective as well on our control scheme, we have here the workflow of our control scheme. So based on the risk-based control, where we are identifying themes or suspect values that we suspect being incorrect, we are using our SQL database to actually withdraw our data from that and implement it to be controlled. And yeah, so after we have identified 150 EPCs, we are making on-site visits and desktop controls based on that. And from our casework, we also get some results and findings. And this EPC flow will make sense later on in my presentation, as I will show you how we can implement a feedback loop to actually provide the knowledge from our results and findings back to our EPC and improve the quality general throughout our entire EPC scheme. Yeah, so the results from Denmark. The results from Denmark are based on our risk-based control on new buildings from 2019, where one of our focuses was to identify missing documentation. So when yeah, I will get back to that in a minute. But we are investigating windows. We are investigating mechanical ventilation regarding the air change. We are also investigating natural ventilation and mechanical ventilation about the specific fan power. So some of the examples here could be that they are withdrew for control by having identical U values for every window throughout the entire EPCs, or it could be that the registered value for air change for mechanical ventilations, the QM, is beneath the value of 0.3, which is the minimum value stated in the Danish building legislation. So just to provide some knowledge on how we issue EPCs for new buildings in Denmark. So it's actually not, it's actually quite different from issuing existing EPCs. So it's more of a control function for the EPC control, consultant, they have to gather necessary documentation, for example, functionality tests, and for the air tightness and so on. And but they still have to inspect the building and control that the actual building complies with the national building legislation. As I also mentioned before, that they have stated some rules. For example, there should be an air change of at least 0.3 liter per second. And only full compliance yields the EPC for new buildings. So if the consultant are not able to gather all the necessary documentation, or they have investigated that building doesn't comply with the national building legislation, they actually have to dump the building, or that's called in Danish. So they have to, then the building will not be approved, and it won't get an EPC actually. Yeah. So in 2019, we controlled 138 EPCs. In this scheme, we had another focus area as well. And as we can see here, we had 100 EPCs which has faults within windows and doors. We had 116 EPCs within ventilation and 103 EPCs within air tightness. And the EPCs here can be represented throughout multiple categories. So how does that divide? So more this is more specific, so we can see through the ventilation here that 44% missed the functionality test for ventilation, which is mandatory for a new building. Or the air change and power usage were registered incorrectly. That's 33%. I can see that the color is not very good here, but 50 EPCs. Or air change and power usage does not comply with the Danish building legislation. So they have registered a value that was actually against the rules. Yeah, and some of the other main factors here within air tightness is that it is calculated or registered incorrectly. And in Windows, most of them were registered with similar U values or with standard U values. And if they are, they have the possibility to correct the EPC, so the buildings will still get an EPC actually. If the window documentation is missing, the EPC can never be issued, so then they will have to correct it to not getting an EPC actually. Yeah, so which initiatives? So this was my scheme from the start of the presentation. So how can we provide these results back to our consultants in our EPC scheme? So we investigated our methodology and came up with 4 possible solutions. So one of the it could be that we identified that our legislation has to be altered in some way. Maybe we found out through our case findings and case work that our legislation was actually too difficult to understand or to implement out in the field. So maybe that could be a solution. One of the other solutions could be working with the EPC consultants' knowledge, and there are two possible ways of doing this. We can all first of all we can alter our education material. So right now we have outsourced our education to private institutes, but we can always alter the rules or differentiate the rules, so they have we can make new materials for the educations. Also we can make, because we have so that would only inflict on the consultants not having the education yet. So we have to also focus on the consultants who's actually already an EPC consultant, and we have the possibilities to make webinars or other materials to improve their their work. But the most important and the most effective one is to make new validation based on our findings. So I have an example in a minute with a concrete example of how we implemented a validation based on our finding from this scheme and from this risk-based control. But first of all, I want to speak a little more about the input validations. So going through that, we have, as I also mentioned, we have implemented the validations in the EPC issuing program, which meaning, as you can see here, I have taken 2 screenshots of our program. So if they are, for example, in these examples, they do not have a construction of the floor, or registered a construction of the ceiling. So it won't be possible for the EPC consultant to actually perform the EPCs, and they will also get, as you can see here, the yellow warnings for not proceeding and issuing. They will have to check it again at least, because they can actually provide the EPC with the yellow warning, but it's more for the unlikely values where we are not 100% sure that it's a fault, but the EPC consultant then get the possibilities to actually comment on the registration and say, yeah, but this is actually the case in this one. Yeah, so as I mentioned, we have around 200 input values, 240, something like that, and we have 350 validations, or 400 or such, in 13 categories. And we have 2 types of validation, as I also mentioned, the yellow and the red one. And the red ones are also the most critical ones. So, as I mentioned, without a roof or without a floor construction. Yeah, so just to show you some examples of the input validations, and I also want to, because there was a question in the chat, if Christian could give an example of a cross input validation. So this could actually be the case in this one here. So if the natural ventilation is below 0.3, as I showed before, liter per second, which is stated in the national building legislation, and the SPF, so the specific fan power, so I changed those letters, is 0, then the consultant will get a yellow validation, because it's unlogical. It won't fit. And also if the natural ventilation is below, or I can see I changed this as well, below or equal to 0.3 as well, it has to be above. So that was some of the rules that we learned we have to implement in our validations based on our risk-based control. And also some of the simple ones, that the area for the exterior walls, roofs, and floors should be above or equal to 0. And also the roofs. So we have some historical national building legislation. So we can see that it was mandatory to have at least 0.33 new value in buildings in 1979. So it's we have a yellow warning stating that it is unlikely that you will register a new value higher than this in a building constructed after 1979. Yeah, and I think that was actually it. So thank you very much.
Thanks a lot, Kasper, for presenting these insights on the Danish case, and also responding to some of the comments. I hope we will have time to also go through the other ones. I hope that in the meantime, George was able to solve the technical issues. Yes, this sounds good, George. We can hear you.
Can you hear me now?
Yes, perfect.
Okay, and I will share the presentation.
I mean, I think it's yeah, as you prefer. Yeah, you can share it or.
Can you see the presentation?
No, not yet.
Again,
Okay. Let Roberta do it.
okay, if Roberta can do it, because I don't. Okay. Thank you very much. My name is George Koras. I work for the Center of Renewable Energy Sources, and I'm responsible for the Greek EPC registry. Next slide, please. The Greek EPC next slide, please. The Greek EPC registry is a Java web application which we developed here in Crash. We started development 10 years ago, and it is still under development. We host it on our hardware, and we support the users. It is owned. The application is owned and administered by the Ministry of Energy. The database is hosted for the database for the online system is hosted on SQL Server, but we also have what we call a database analysis environment or statistics environment, which uses a MySQL database, and it is there for creating statistics and analyzing the database. Now, the software for the test consists of Java applications and Visual Basic code that we developed. A part of it was already developed for a different project. And we are also working, not in the context of X-tendo, we're also working on software for online presentation of results queried from the statistics database. In the context of X-tendo, we worked with a sample of 500,000 EPCs, which were issued after 2016 for reasons that I will explain later. Overall, the database contains more than 2 million, closer to 2.5 million EPCs. Next slide, please. The Greek National EPC Calculations Engine is the software that does the calculations for the EPC. It was developed by the National Observatory of Athens for the Technical Chamber of Greece, and it was incorporated into our web application. So the data are stored, the engineering data are stored in XML files, which are uploaded along with various other data in our web application. And the calculations engine is used by our web application to redo the calculations and populate the database. There is a major problem is that there is no formal definition of the XML format used by the calculations engine. It wasn't designed as a data exchange format between different applications. It came to be used that way. And the absence of a formal definition of the XML format resulted in incompatibilities between our web application, the EPC registry web application, and the calculations engine. And more on that we shall see in a minute. Next slide, please. Now, in the first level checks, we checked 17 parameters such as U values of roofs, windows, walls, and primary energy consumption for heating or hot water, efficiency and power of heating and cooling systems, etc. The checks that we implemented was one, if the value can be extracted for the XML file. This refers to the incompatibilities that I talked about in the previous slide. We have we have cases that our software cannot extract the value from the XML file, although the value is there and is being used in the calculations. Is the value not null? Is it there? If it can be extracted. And then we have parameter-specific checks for its specific for its parameter. For some parameters, we require it to be more than 0. For others, for percentages, it has to be less than 100, etc. Next slide, please. These are some results that we have we got from our database analysis software. We see that in most cases, the issues that we cannot extract the value from the XML file, the incompatibilities, are around 10%. For example, in the U values of Windows, we have 13.66% of EPCs that, although the value is correct, we know that it is there because the calculations don't fail. We know that it is there. We know that it is taken into account in the calculations. We still cannot extract it from our software. The failures of the checks are 2.2% for the U values of Windows, and the rest 84% were cases that the checks were successful. Similar results for the power of heating systems. Next slide, please. And also similar results for the efficiency of cooling systems. So we have a rather large percentage of failures that are due to the incompatibility of the systems, and this is something that we can improve. This is something that we can work on. It's not; they're not real failures of the EPCs, of the EPC data. Next slide, please. Now, for the second level checks, the approach that we took, as did the other implementing partners of X-tendo, was finding the outliers, finding these parameters of these EPCs that were a lot different from the main bulk of the EPCs. To do that, we clustered the database according to building type. For example, we have residential single-family houses, multi-family houses, educational buildings, and offices. According to construction period, before 1981, between 1981 and 2010, and after 2010, these are years that the legal framework for construction changed considerably, and that's why we picked those years to cluster our database. Similarly, for the renovation, our clusters is not renovated between 2010 and 2017, and after 2017. And of course, the climate zone, we have in Greece 4 climate zones, A to D. Which we used 13 parameters, which are 13 parameters. For example, primary energy consumption of the whole building, primary energy consumption for heating, cooling, hot water, and lighting, U values for windows, roofs, walls, etc. Heating and cooling systems and efficiency of power, and solar collector area. We defined outliers as values that are lower than the second first percentile, and above the 98th. Next slide, please. And these are some results. We're looking at the results for residential houses, single-family houses, and we're looking at primary energy consumption for hot water. can see here that the first this is primary energy consumption for hot water, not renovated, and all climate zones. And we can see the distribution for each percentile. Next slide, please. The same for U values of roofs. We can see that the U values are more closer to around a value of 0.5. And then we have, next slide, please. Our final insights. I thought I had one more slide with results. Sorry about that. Our final insights. After the initial database analysis, the text can be incorporated in the EPC registry web app, and if a specific value of the EPC is an outlier, we propose to issue a warning to the energy experts before, of course, before the final submission of the EPC, so they can either take responsibility and go forward with submitting the EPC if they are sure that this is something correct and expected, or they can go back and correct the error if there is one. If this is done, we need a periodic update of the percentiles, taking into account new EPCs that are added in the database every day. And this is still a considerable computing load. We certainly cannot do it with our present hardware, but can be done. It's not the kind of computing load that cannot be done with a little more modern hardware. We have started developing online queries in the statistics DB, the statistics database that we built for identifying risky EPCs, for online identifying risky EPCs by employees of the Ministry of Energy, supplying, modifying, parameterizing their checks online and viewing results and identifying risky EPCs. We found that our clustering was rather optimistic. There were the initial clustering was rather optimistic. We had many clusters that had a very low number of EPCs per cluster, and that's why we concentrated on specific clusters or unified clusters to less. The incompatibilities between the calculation software and the EPC registry software were an important issue that we were able to demonstrate its importance and motivate people to start working on this, to start working on a better data format design for the XML data files, so that we can work better with this data. Next slide, please, which is the last one. That's it from me. I don't know if you want to ask questions now.
Yeah. Thanks a lot, George, for these insights into the Greek case. We have only a few minutes left now for questions and answers and discussion points. But so I propose to I try to pick a few of the comments raised in the chat and in the questions and answers. And I had the impression one important line of discussion and or a series of comments referred to this question. as Ina said, and also Casper and Christian, there are quality checks, or can be quality checks along the whole chain from the issuing process until the EPC database. So how can it be best combined, such a process of doing quality checks both in the EPC databases and already in the issuing phase? So does one of you have a response or to this question, or a view on this point? Who wants to?
Maybe can I try?
Please, Fabio. Yes.
Well, from our point of view, from the Italian point of view, or maybe based on the Italian experience, I think that, well, the quality control at the issuing phase is very, very important. So there are a lot of checks that can be done directly before issuing, as some of our attendees pointed out in their question in the chat. But then depends on the situation that you have to manage. So if you have to start from scratch, then of course the best thing to do is to have a system which corrects automatically before the issuing, during the issuing phase, preventing the issuing of an EPC which has big mistakes. In our case, so the Italian situation, it's a bit complicated. We have a regional competencies and regional jurisdiction, and so we had to deal with the already existing databases, which were just partly checked and analyzed. And so the analysis, let's say the analysis in the issuing phase was something that it was not really possible on the already existing database. So let's say, well, and of course the issuing, the control phase during several steps is very important. So at the issuing moment, but also on the database, and also the feedbacks to the issuers.
Thanks, Fabio. Anything to be added from, I don't know, from Casper or George's side?
Yeah, so if I should add something, Lucas, I think it's important to say that it actually has two different purposes. So checking through when performing the EPCs avoids mistakes in the EPCs, that's correct. But how do we get the knowledge to implement further validations? So that's gained by performing the risk-based control later on to get the knowledge of where the validation actually has to be improved. So I think they are equally important, but they have different purposes.
Thanks a lot. I think that was a very, very important point. George, I'm not sure. Did you also want to add something?
Yes, in our case, there have been software design issues, software that didn't take values that it should take. But we also must take into account that when Greece started EPCs, people weren't very sure what to expect. So they preferred, the people who wrote the calculation software preferred to leave as many options as possible to the energy experts. So we have more free fields, more free values than we should have. Of course, there are some checks that are done on the software that does the calculations, and then some further checks that are done on our side on the web application. And these checks, when they fail, they stop the EPC from being issued. And in this work, we try to go a step further, identify first level check, identify fields, values that should be checked before the EPC is issued, and also find values that are just risky and should be brought to the attention of the energy expert, but still leave it to them to decide whether they will proceed or not. So the checks that we are talking about in this context are more will result in warnings rather than errors for the user.
Yeah, thanks. Good to hear how you see these quality checks along the whole chain to be combined. Unfortunately, we are already running out of time. We are 2 minutes behind the schedule. Although on the other hand, we would have a lot of additional questions. Maybe just to mention that in the Q&A section there was a question on the number of issues, number of EPCs issued, and I posted a link to an X-tendo report where this is documented. There was also a question on the how it was called performance gap between actual between calculated energy demand and actual measured and real energy consumption. Here I also want to mention that we have a special feature which in the X-tendo project dealing with this question of how real energy consumption can be implemented in EPCs as well. We also had a comment on the good practice of Denmark with the open access data. I very much agree on that, and I realize we had this now quite frequently in the webinars. This issue of open access and how we can further contribute to following these best practice experiences from some countries like Denmark. In this sense. Sorry for being not able to take up more questions, more comments from your side, but I hope we can be in touch in one of the next workshops and events in the context of the X-tendo project. Again, thanks to all the panelists for your interesting insights and presentations. Thanks for the audience for your active participation in the chat and in the Q&A section. Yeah, wish you a nice day, and thanks everybody. Goodbye.
Thank you. Bye.